Okay, so here we're back to where we were looking at before. When we have an objective lens and an eyepiece, Newton wasn't very happy with this, all right? And why he wasn't happy was that glass, when light passes through it, will spread the light out into the colors of the rainbow. Now, in the case of a lens, it doesn't do it much, but around the edges of objects, you would always get sort of a rainbow ring when you use lenses for both an objective lens and an eyepiece. All right, so Newton wanted to do better than that, and he knew that a mirror does not spread out light, and we know that we can create images with both mirrors and lenses. All right, so if we could create this image in here using a mirror instead of a lens, we would be able to get rid of the rings of color, the chromatic aberrations that would appear when you're trying to look at something and would get in the way of it. So let's go over how Newton was able to do that. Okay, so this is a Newtonian reflecting telescope. There's a significantly better picture in the book. So we were playing Pictionary, you would never guess this is a Newtonian reflecting telescope. But let me explain a few key features of this. Okay. One key feature is this end is open. There's no lens here, right? Rather than focusing the light using an objective lens, there's a mirror back here. And it's a concave mirror. But once again, it has so it's a concave mirror which can focus the light. But it will once again have a large focal length. It's serving the same purpose as the objective lens. It's just a mirror now, all right? And so a lot of light can come into the tube of the telescope. Let me change colors here. And bounce off of this mirror, okay, and hit right here. Now you wonder what that's for. That's a little mirror that's at a 45-degree angle. And what a 45-degree angle mirror does is it will reflect the incoming light in such a way it's almost as if it were continuing along a straight path, but it takes it out to the side where you have an eyepiece, which is just like the eyepiece in the other telescope. Okay, it's basically a magnifying glass. Okay, and now you may wonder, doesn't that mirror in the middle of things obscure the object that you're trying to look at? And the answer is not really, because the object's very, very far away. So light from it is coming into the tube all around. Some of it does get blocked by that mirror, but 90% of it makes it past the mirror and comes back out and will reflect over. Okay. Now the key is, just like for the other telescope, is we get a little image right in front of the eyepiece. So right in here, we get a little image of what it is that we really want to look at. And the geometry is it's just bent around by having that 45-degree mirror, but the geometry is the same. The longer the focal length is, the longer the distance is from where this back mirror is and where the object comes, the image, I'm sorry, is projected. If you were to add up this length and this length to here, that would be the focal length of the back mirror of the telescope. If we didn't have the 45-degree mirror, the image would be formed out here, but instead it is channeled over into where the eyepiece is. We can't have the whole eyepiece in the middle of the telescope, so we bounce the light out to the side, and then we're able to see what's bouncing out to the side with the eyepiece. So once again, the magnification is an angular magnification, and it basically comes down to the focal length of the objective mirror this time over the focal length of the eyepiece, and that gives us the magnification like before. Okay, so we need two optical devices. Okay, one is a mirror that creates a small image for us to look at, but it's very close to us. okay? Whereas before, with our naked eye, we were looking at a very large thing, but it was extremely far away. So the telescope allows us to look, use a magnifying glass on a small version of that image up close, and we get an angular magnification out of that. So that's how the reflecting telescope works. And the nice thing is the red, orange, yellow, green, blue, indigo, and violet light are all reflected at the same angles by the mirrors. So there's a lot less chromatic aberration because you have one lens instead of two. And if you look through a magnifying glass, you really don't see much of that chromatic aberration. So it's more of an issue with that very large lens that was the objective lens on a standard telescope.